In this video, we are going to begin talking about similar figures, which is kind of a review from 7th grade last year, but we're going to put some 8th grade vocabulary with it and just kind of hope that these concepts will blend together a little bit easier. Similar figures are the same shape, but different sizes. So their sizes are changing, which means what happened here was a dilation. Similar figures are proportional. When two shapes are proportional or similar, this just means that the figure's angle measures are congruent. Congruent just means that the value or measure is equal. Let's pretend I have a rectangle. That means all of the angles are 90 degrees. I'm going to have a similar rectangle, but I'm going to make it smaller. Same rectangle, all of the sides are proportional. Still a rectangle, so I know that all of the angle measures are 90 degrees. That's how I know for sure that angle measures are congruent. The figures are related by a common ratio. Ratio just means fraction. That fraction is known as the scale factor, which we have been working with a lot lately. Scale factor was the letter K, and maybe if you remember back to like Unit 4, proportional, let's talk about those proportional and non-proportional relationships. We said for a proportional relationship, instead of using y equals mx plus b, we used y equals kx. So we were using the same scale factor letter there as well. So the sides are also proportional. Sorry, I forgot to fill that blank. We know from yesterday that to find the scale factor, we take something from the image and divide it by something from the pre-image. The image is something new, so something new goes in the numerator, and the pre-image is the original figure. In this first example, it says that these figures are similar if all of the corresponding sides are proportional. Proportional just means that their ratios, or fractions, are the same or equal. Corresponding means matching. So I'm looking at my rectangle and I see that this side corresponds or is in the matching position as this side in the big rectangle. If I moved this rectangle onto this rectangle, the pink sides would share sides. Seven corresponds with 10.5, 10.5. I'm going to go ahead and talk about this top side length corresponds with the smaller rectangle's top side length, and the green side length corresponds with the left side in the small rectangle as well. And remembering about rectangles, I know this side is 2, which means the top orange side here is 2. I know this side is 3, so the top side here is also 3. And we know that the green side here is 10.5, so this green side here is 7. I have all pairs of my sides corresponding with another side. So we're going to get started with determining if this is proportional or not. So I'm going to pick to look at the ratio 2, which corresponds with 3. That's one of the ratios we have to compare. Another ratio we have to compare is we picked to go from the small rectangle to the big rectangle. So in the numerator, I need to take from my small rectangle again, 7. 7 corresponds with 10.5. Now we're going to look at the orange sides. We have to pick from the small rectangle first. The small rectangle's orange side is 2, which I've already written down here. And the big rectangle's orange side is 3, so that fraction would be 2 over 3, which we already have written down here. Obviously, 2 over 3 and 2 over 3 are equal to each other, so we're not going to evaluate that fraction. We're not going to do the extra work. The green side's ratio, remember we're going small to big, is 7 to 10.5. 7 to 10.5. And again, we've already got that written down, so we're not going to waste our time evaluating the same exact fraction again. All right. We're going to evaluate these fractions. It's probably easiest to change all of the fractions to decimals so we can easily compare the numbers. So I've got 2 over 3 from the pink sides, and 2 divided by 3 is the same as 1.5. In my blue sides, 7 over 10.5, that's 7 divided by 10.5. That quotient is 1.5. So now both of these ratios, or fractions, were equal. Since the ratios were equal, all of my corresponding sides were proportional, which means these shapes are similar. Looking at the rectangles to the right of that, we've got 4, this side is also 4. 4 corresponds in the big rectangle with 5. This is also 5. And 6 in the small rectangle corresponds with 9. Oh, oops. And this top side is also 6 in the small rectangle. The top side is 9 in the large rectangle. To determine if these figures are similar, I need to set up some fractions or ratios and see if those ratios are equal. The first ratio I'm going to set up, I'll use from my pink corresponding sides. I'll say 4 from the small rectangle corresponds with 5 from the large rectangle. When I do 4 over 5, that takes care of checking the other pink side's ratio as well. Next, we're going to look at, we picked from the small rectangle first. The small rectangle's value is 6, and 6 corresponds with 9 from the big rectangle, so our ratio or fraction is 6 over 9. When we checked this 6 over 9, that's also taking care of the ratio you get using the top corresponding sides. So we're not going to write 6/9 again. Now we're trying to determine, are these fractions equivalent? And it's really easy to check to see if these things are equal once I've changed them to decimals. 4 over 5 as a decimal is 0.8. We just type in 4 divided by 5. 6/9 as a decimal. 6/9 as a decimal is 0.6 repeating. Now these decimals are not equivalent, not equal, meaning those ratios were not equal. So the corresponding sides are not proportional, which means these figures are not similar. Not similar because the ratios were not proportional or equal. Next, we're going to go backwards, and we're going to say the figures below are similar. These are similar figures, and we want to know what is the scale factor. remember to find the scale factor, we need something from the image over something from the pre-image, or something from the new shape over something from the original shape. Now, these figures are marked with A and A prime. A prime is got the prime notation, so I know that that's an image. So 24 corresponds with 12. 24 from my image corresponds with 12 from my pre-image. And 24 over 12 is 2. So I'm saying that the scale factor, or K, is 2. I'm not looking at the other sides right now. I know that they have to equal 2. I know they have to equal 2 because these figures are similar, which means all of the side lengths, the corresponding sides, are in the same ratio. We can verify that by checking 20 over 10. 20 over 10 is 2. We can look at image 6 over pre-image 3. 6 over 3 is 2. And again, we can look at this 20 and this 10. That's again 20 over 10, which is, we've already determined, was 2. So if we're trying to just find the scale factor in objects that we know are similar, you just need to pick a pair of corresponding sides. Make sure you're dividing the new thing, or the image, by the pre-image. Otherwise, you won't get the scale factor. You'll get the reciprocal. This says the figures below are similar. What is the scale factor? And they've labeled that this figure is the original. If this is the original, I know that this is the new thing. I know that I need to set up my ratio, my fraction, my scale factor is something from my new object, or my image, over something from my pre-image, or my original. If I picked 24 from my new thing, or my image, I have to pick the side that corresponds with that from the original shape. This 8 is in the same position as this 24, so we're using 8 from the original figure. Well, 24 divided by 8 is 3. So the scale factor, or K, is 3. Below, I want to determine if the figures are similar, and if they are, I also want to know the scale factor. And what I did not do, because I forgot to type it, was explain that this is the original A, and this is the new thing, A prime. And that this is A, and this is A prime. I first need to determine, are these things similar? So I have to find all of the corresponding sides. In A prime, the 8 corresponds with 12 from A. In A prime, 12 corresponds with 18 from the original A. And from A prime, again, the third side, 18, corresponds with 27 from the original figure A. So we have 3 ratios that we need to check. You'll notice that when I'm not trying to find the scale factor, it doesn't matter which one is new and which one is original, as long as you're picking from the same rectangle to go on top and the same, not always a rectangle, polygon to go on the denominator. Below, this is going to matter eventually, because if these things are similar, then I also want to know the scale factor. So I'm going to set this up like they are similar, and if they are, I'll already have the scale factor, so I don't have to do that extra work. So we're going to pick things from A prime to be in the numerator, and the side lengths from A in the denominator. A prime has a pink side of 8, and the pink side from A is 12. So the fraction is 8 over 12. Now I'm looking at the orange side. We picked from a prime first to be in the numerator. The orange side in a prime is 12. So 12 is in the numerator now. And its corresponding side from original a is 18. So the fraction is 12 over 18. The third ratio then is something from a prime. My blue a prime value is 18. Its corresponding value from the original a is 27. Now I'm going to determine what those values are as decimals, because decimals are easy to compare. 8 over 12 is the same as 4 over 3 or 4 over 6 or 0.6, repeating. 12 over 18 is the same as 0.6, repeating. 18 over 27 is the same as 0.6, repeating. So all of those values are the same. Since they are all the same, I know that, sorry, I was looking for this pen. These ratios are all equal, which means, yes, this is similar. These two shapes are similar. I've already found that the scale factor is 0.6 repeating. We usually like to keep scale factors as fractions. The fraction that matches 0.6 repeating in most reduced terms is 2 over 3. Again, you guys can reduce fractions on your calculators by using math. Enter, enter. Looking at the next little problem here, this asks, are the figures similar? And if they are, what is the scale factor? So we're going to use the same little process here. First, I'll find all of my corresponding sides. 39 corresponds with 52. And this 39 is the same as that side length. I know because of the markings, but also this is just a property parallelograms have. 52, that's also 52. These are also corresponding sides. And my other pair of corresponding sides is 15 corresponds with 20. That takes care of this set of corresponding sides as well. Because I want to avoid doing extra work, when I check to see if they're similar, these figures are similar, I'm going to use the ratio a prime over a. Looking at a prime, I'll pick the pink side first, 39. The thing that corresponds with 39 from original a is 52. And now I'm looking at the blue side. 15 is from a prime over its corresponding side from a is 20. Now you're looking at, are these fractions equivalent? So you want to evaluate them and probably get a decimal value. 15 over 20 is the same as 0.75. You can get a calculator out for this step. You would have the numerator divided by the denominator, 39 divided by 52.75. Now these values are equal. Since these values are equal, the shapes are similar. Yes, similar. And k is 0.75. The scale factor is 0.75. 0.75, the equivalent fraction there is 3/4 in simplest terms. The very last question asks which figure is similar to the original figure and what is the scale factor. So the original figure I will highlight in, well, I'll use the pink pen to outline it. Sorry, I'm not going to outline it. 4 in the original figure corresponds with 6 from A, 4 from the original figure corresponds with 10 from B. I'm setting it up this way. I want to know what corresponds with what, and then I will use the image or the new thing over the original thing as my ratios, because one of these things will be similar to the original figure, and I want to know the scale factor as well. So if I use the new thing divided by the original thing, I'll end up with the scale factor for whichever one of those shapes is similar to the original. 7 is corresponding to 11 from A and 17.5 from B. 6 corresponds with 10 from A and 15 from B. And 9 corresponds with 13.5 from A and 22.5 from B. So I'm just going to do some work with, let's look at just A for now. When I'm just comparing A and the original, we need the new thing, so something from A over something from the original. Looking at, I have an orange pen in my hand, so I'll use the orange thing first. Something from A is 13.5. 13.5 corresponds with 9. Next, I'll look at 10 from A. 10 corresponds with 6. And then I'm using 11 from A, so 11 in the numerator. 11 corresponds with 7, so 7 in the denominator. I've got 6 corresponds with 4. I know that 6 over 4 is 1.5. And I know that 10 divided by 6 is 1.6 repeating. You can go ahead and check the other values if you want. You don't have to, because already these things are not equivalent. Since those two ratios aren't the same, A cannot be similar to the original figure. So it's not A. Now let's do some scratch work for B. When I look at the ratios for B and the original figure, we need something from B, the new thing, in the numerator, divided by something from the original shape in the denominator. I've got 10 from B. 10 corresponds with 4. Now I've got 17.5 from B. Corresponds with 7 from the original. I've got 22.5 corresponds with 9 from the original. And then from B we've got 15, and 15 corresponds with 6 from the original. Now you want to check out all of the ratios. You want to probably divide them out and get decimals. We know that 10 divided by 4 is 2.5. We'll look at 17.5 divided by 7. 17.5 divided by 7 is 2.5. 22.5 divided by 9 is 2.5, and 15 divided by 6 is 2.5. All of those ratios are equal to 2.5, which means the original figure is similar to B. And the scale factor is 2.5. Again, we like to keep these as fractions, so we will say 5 halves instead. I do want to point out something on your homework. This is page 136 in your binders. In your homework, that's page 137. The top 4 problems just want you to determine if the polygons are similar or not. So it doesn't really matter which one you're calling new and original, because I don't need the scale factor there. The bottom 4 problems tells us each polygon is similar, so I know these are similar for sure. I just want to know what is the scale factor from the smaller shape to the biggest shape. So we start at the smaller shape and we're ending at the biggest shape. So we always end in our image. That's the new thing. And we start at the pre-image. So this is saying that all of our smaller shapes are the pre-image and all of the bigger shapes are the image. So we're going through in number 5, 24 or 60, which one is smaller? 24, so this is your pre-image and this is the image. And number 6, 16 or 20, 16 is smaller, so that's your pre-image. And 20 is bigger, so that would be your image. If you have questions or concerns about the content in this video, feel free to send me a message on Schoology, an email, or drop a comment on the video, and I'll be glad to get back to you as soon as I can.